Hi, 8th graders. This is the math video for lesson 4-4, which is talking about the concept of greatest common factor. And it's also talking about something called factoring of expressions, which uses greatest common factor to do the task of factoring the expressions. So the first thing I'm going to do is I'm going to run through the two different ways that a person can find greatest common factor. There are two ways. Your book talks about them in examples 1 and examples 2 on 164. Let's start with two numbers. How about the numbers 15 and 50? Here's method 1 for finding greatest common factor. The first thing I do is I think about the number 15 and I ask myself, what are the different ways in which I can multiply two numbers together to make 15? And I wrote them out here. 1, 3, 5, and 15. 1 times 15 is 15. 3 times 5 is 15. And that's it. Those are all of the factors I know of for multiplying together numbers to get 15. I'm going to do the same thing with 50. 1 and 50, 2 and 25, 5 and 10. That's it. Those are the only ones I can think of. I don't know if you can think of any others, but I can't. Then, the next step. I look for the factors that they have in common. They have a 1 in common. They have a 5 in common. And I think that's it. So what's the greatest common factor? Or in other words, the greatest factor that both of them have in their list? In this case, the greatest common factor is 5. That's method 1. Method 2 of this same type of work is we take these two numbers and we create factor trees for them. Remember factor trees? And then we write down the prime factorization of 15 and the prime factorization of 50. See it there? 3 times 5 right there. 2 times 5 times 5 right there. And we ask ourselves, what do they have in common? In this situation, they had a set of 5s in common. So once again, what's the greatest common factor? 5. Just like we found out up here. Two different methods. Let's try with a different set of numbers. How about 64 and 80? This one's going to be a little bit more complicated because these numbers have a lot more factors. I'm thinking 1 and 64. I'm thinking 2 and 32. 3 does not work, but 4 works. 4 goes into it 16 times. 5 does not work. 6 does not work. 7 does not work, but 8 works. 8 times 8 works. So those are the factors of 64. I don't need to repeat the 8, so I'm going to get rid of that. What are the factors of 80? 1 times 80. How about 2 times 40? 3 doesn't work, but 4 works. 4 times 20. 5 works. 5 goes into it, 16 times. Does 6 work? No, it doesn't. Does 7? No. 8 works. 8 times 10. And we're done. So what factors do they have in common? They have 1s, 2s, they have 4s, they have 8s, and they have 16s in common. Anything else? Nope. So what's the greatest common factor? 16. 16. Okay, that's method 1. Now method 2. Let's break down the 64. How about 8 and 8? How about 2 and 4? How about 2 and 2? Wow. So, what's the prime factorization of 64? Isn't it 2 times 2 times 2 times 2 times 2 times 2? Right? Got all of these prime numbered 2's there. How about 80? Let's break down 80. How about 8 times 10? How about 2 times 4? Hey, there's a prime number. How about 2 times 2? Hey, there are some prime numbers. How about 2 times 5? Hey, there's some prime numbers. And so we get, now, what do they have in common? They have a set of 2's, another set of 2's, another set of 2's, and another set of 2's in common. Do they have anything else in common? Nope. What is 2 times 2 times 2 times 2? Isn't that 16? Yes, it is. So the greatest common factor is 16, just like we got up here. Same answer. Let's try it again. Both methods. Gotta think through both methods and know how to do them. How about 36 and 50? 36 and 50. Well, what are some ways we can get 36 if we multiply some numbers together? How about 1 and 36, 2 and 18? How about 3 and 12? How about 4 and 9? We're running out of room. How about 6 and 6? That's it. Ooh, squeezed it in there. Got it. How about 50? 1 and 50. How about 2 and 25? 3 doesn't work, 4 doesn't work, but 5 works. 5 times 10 works. 6, 7, 8, 9, none of those work. Okay, so what do we have in common? Set of 1's, 2's, 5, 10, 20. Wow. What's the greatest common factor of these two numbers? It's just the number 2. 2 is the biggest factor they have in common. Okay, let's try method 2. If I break down the 36, I can do that by saying, how about 4 times 9? And then the 4 becomes 2 2's, and both of those are prime. The 9 becomes 2 3's. So the prime factorization of 36 is this. What about 50? What's its prime factorization? How about 2 times 25? That's prime. Break down the 25. That's 5 times 5. So we end up with 2 and 5 and 5. What do they have in common? All they have in common is one set of 2's. So that means the greatest common factor is 2, just like we got up here as our answer. Hopefully you're starting to get the hang of this. How about numbers like 16 and 24? Give me some numbers that multiply together to make 16. 1 and 16. How about 2 and 8? How about 4 and 4? We don't need the second 4. How about 1 and 24? How about 2 and 12? How about 3 and 8? How about 4 and 6? What do they have in common? A set of 1's, a set of 2's, a set of 4's, a set of 8's. That's it. So what's the greatest common factor? The greatest common factor is 8. Now, what about the other method, the second method? We can make factor trees. How about 2 times 8? Hey, that's prime. How about 2 times 4? Hey, that's prime. How about 2 times 2? Hey, those are prime. So 16, didn't we do this one before? I think we did. We did the 16 before. And what about 24? Well, that could be 3 times 8, right? Hey, the 3 is prime. How about 2 times 4? Hey, the 2 is prime. How about 2 times 2? Yo, those are prime. So we write down the prime factorization, which in this case is 2 times 2 times 2 times 3, right? And now what do they have in common? They have this, this, and this in common. So what's 2 times 2 times 2? Isn't that 8? You betcha. So our greatest common factor is 8 again, just like it was up here. Okay. What about those ones where they're going to get sneaky and attach variables to the end of them? Like, for example, what if I had 12k squared and 40k, and somebody said, what's the greatest common factor of that? Well, let's try both methods again. What are the ways in which you can make 12? These are the ways I can think of. What are the ways you can make 40? 1 times 40, 2 times 20, 4 times 10, 5 times 8. What's the biggest number they have in common? They have 1s in common, 2s in common, 4s in common. That's it. So it sounds like they have a 4 as their greatest common factor, but don't forget about these k's. What if I write times k here, and what if I write times k there? What do they have in common here? They have a k in common. So that means the greatest common factor is 4 times k. 4 times k. Okay? Now, what time are we at? 10? Okay. Now, what about this other method down here? If I'm going to use the factor tree, well, we can still factor it. This is what? 4 times 3. And this is 2 times 2, so boom, boom, boom. There's the factoring of the 12. But let's also think about the fact that there's a k there, isn't there? So it's really 2 times 3 times k, isn't it? Isn't that really the prime factorization of this? And over here, 40 is really 8 times 5, and the 8 becomes 2 and a 4, and the 4 becomes 2 and a 2. Right? So we've got prime, 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 and prime. That's supposed to be a 2 there. I know, it doesn't look like one. So what do we got? Oh, wait a minute. Don't forget about the k. Yeah. So we really have 2 times 2 times 2 times 5 times k. Now, if I line those up, one on top of the other, what do they have in common? Bump, bump, and bump. What's 2 times k? 4k, which is the same answer I think we got up here. Yep, we got 4k up there. So that's greatest common factor. What about this business of factoring expressions? Like, let's say, for example, I had 5 times b plus 15. What do they mean by factoring the expression? What they really mean, in my mind, is they're kind of like doing the reverse of the distributive property. They're looking at this term, and they're saying, what one number can we divide out of both of those? And we're trying to think of the very largest number that we can divide out. And in my mind, I'm thinking we can divide out of this and this a 5. And look where I put it. I put it out in front of a parentheses. And when I divide out the 5, I'm left with a b here, and I'm left with a 3 here. So I end up with 5 times the quantity of b plus 3. Doesn't that look like the reverse of the distributive property? I hope it does. Let's try another one. What if I have 7 times t plus 49? I'm looking at this and I'm thinking, what can I divide out? Well, I can divide out a 7. And if I do that, I get 7 times the quantity of t plus 7. 7 times the quantity of t plus 7. Because I'm dividing out a 7 from this, and I'm dividing out a 7 from this. I'm looking for the biggest number I can divide out. Okay, let's try another one. How about if I had 6w plus 18? And I started thinking, what can I divide out of those two numbers? I know I can divide out a 2. 6 divided by 2, 18 divided by 2 works. I know I can divide out a 3, 6 divided by 3, 18 divided by 3. But guess what? There's a bigger number than 2 or 3. It's the number 6. Let's divide out a 6 from both terms. And what do we get? We get 6 times the quantity of w plus 3. Remember, it's kind of like the opposite of the distributive property. What if I had something like this? 100 plus 50x. What can I divide out? Well, I know I can divide out a 2, but I also can divide out a 5, and I can also divide out a 10. But guess what? There's bigger numbers than that I could divide out. I could divide out a 25, and finally I could divide out, I'm going to divide out a 50 from both of these terms. And when I do that, I get 50 times the quantity of 2 plus x. 50 times the quantity of 2 plus x, because that's the biggest number I can divide out of these terms. Let's try another one. What if I had something like 24 plus 8g. 24 plus 8g. Again, what can I divide out of 24 and divide out of 8g? Well, I can divide out 2. What else? I can divide out 4. Anything else? How about 8? Yeah, 8 is the biggest one I can divide out. By the way, in my mind, this is actually greatest common factor I'm thinking about here, right? I divide out the 8 and I get 3 plus g. There's my final answer, 8 times the quantity of 3 plus g. Hopefully this makes sense what we're doing here. Thank you, 8th graders. Talk to me if you have questions.